Welcome to Spring LIB.
If the momentum of object A is equal to the momentum of object B, then does kinetic energy of object A have to equal kinetic energy of object B? And to show whether this is true or not, one way is to either prove generally whether it's always the case, or generally whether there's a case where it's not true, and then you have your answer. But first, let's quickly go over what momentum and kinetic energy are individually. So, kinetic energy is the energy an object has from its motion, and momentum is the tendency of an object to keep moving. Now, mathematically, these ideas can be written as follows. Momentum is mass times velocity, and kinetic energy is equal to 1/2 times the mass times velocity squared. Now, just by looking at them, you should see that momentum closely resembles the basic form of a linear function, and kinetic energy closely resembles the basic form of a quadratic function. And in fact, if you were to graph these, you would see just that. Now, it's also worthwhile to note that momentum is a vector, so it has magnitude and direction, and kinetic energy is a scalar, so it just has magnitude. So off the bat, you can see that these two functions just fundamentally are very, very different measures of how an object moves. And this leads me to believe right off the bat that maybe if momentum of object A is equal to momentum of object B, that kinetic energy of both objects does not have to be equal. And that becomes kind of clear when you look at how velocity changes with each respective measure. As velocity increases, kinetic energy increases far greater than that of momentum as velocity is changing. So one way to do this is to go over it mathematically. Momentum is equal to mass times velocity, and kinetic energy is equal to 1/2 mass times velocity squared. Now we can write them as a function of each other and then try to understand how they relate mathematically. So to do that, we can rewrite momentum as follows. Then we can plug it in to the velocity term in kinetic energy. That will result in the following equation. Now, we know that momentum of A is equal to momentum of B. So in a case where you have kinetic energy A equals momentum of A squared over 2ma, and you have another case, kinetic energy of B is equal to momentum of B squared over 2mb. Now, we know that the momentum in both cases are equal. That's given. So these two top terms are equal. However, momentum A and momentum B can be any real number. So let's imagine a case where mass A is far less than mass B. Well, if you're dividing the same number by either a smaller number or a bigger number, if you divide the same number by a small number, you're going to get a bigger number as a result than if you divided that same number by a bigger number. So intuitively, we will find that kinetic energy of object A with the smaller mass is going to be far greater than kinetic energy of B. I know this is super colorful, but colors always help me to see the solution better. But right off the bat, we now have a general example showing that kinetic energy does not in fact have to be equal between two objects who share a similar momentum. But just to solidify this, let's quickly go over a real world example. So imagine you have an RV and you have a rock. Now, the RV has a mass of 1,000 kilograms and it has a velocity of 1 meter per second. And let's imagine that the rock has a mass of 1 kilogram, but a velocity of 1,000 meters per second. Now, if you assume this to be the case, let's look at what the calcs would show about the discrepancies or similarities between the momentum and the kinetic energy that each have. So you would find that the momentum of the RV is equal to 1,000 kilogram meter second. And you would find, actually, let's use a different color. You would find that the, you would find that the momentum of the rock is also equal to 1,000 kilogram meters per second. Now let's look at the kinetic energy. This is where it's going to get interesting. Equal to 1/2 times 1,000 kilograms times 1 meter per second squared, which is going to yield an answer of 500 joules. Now the kinetic energy for the rock is going to be 1/2 times 1 kilogram times 1,000 meters per second squared, which is going to be 500,000 joules. So you can see right here in this real world example that two objects, an RV and a rock, can totally have the exact same momentum, but completely different levels of energy, kinetic energy. And we're talking about a factor of 1,000. So this very clearly demonstrates that no, kinetic energy does not have to be equal between two objects that share the same momentum.